Okay guys, this is 6.2 Law of Cosines. We're going to use the Law of Cosines to solve oblique triangles. I know we did it before, but now this is for other situations. And the Law of Cosines to model and solve real life problems. And we're going to use Heron's area formula, which you've probably already used. Okay, so there are two forms. There's the alternative and the standard form, but my suggestion, just keep this form here. Who cares about the alternative? We can always solve for whatever we need. That way you're only remembering one. One thing you need to remember, if you start with A, you end with A. If you start with B, you end with B. Then the other stuff is all the stuff you haven't used yet. Okay, so we're going to start example 1, and we're going to go ahead and solve for cosine, or for the angle A. So we're going to go 8 squared is equal to 19 squared plus 14 squared minus 2 times 8 times 19 cosine of A. And we've got 64 is equal to 361 plus 196 minus 532 equals the cosine of A. When we move everything over, we end up with the cosine inverse of 493 all over 532. Plug it in your calculator, and A is approximately 22.1. Okay, so now let's do C. So C, to do C, we want to do 14 squared equals 8 squared plus 19 squared minus 2 times 8 times 19, the cosine of C. Again, going through and doing all of the math, we end up with the cosine inverse of 229 all over 304, which is going to be C. So then C is approximately 41.1 degrees. Okay, now we have to think about what we've got here. So if we want to find B using the first one, right? So if we want to go here, then to find B, we're going to go 180 minus 221.1 minus 41.1, which gives us 116.8 degrees. Okay, go ahead and pause, try the checkpoint, and come on back. Let's see how you do. So the checkpoint is A is approximately 26.38, B is approximately 36.34, and C is approximately 17.28. That's a 7. Okay, so one of the things we need to be careful of here is we need to find out if there's possibly two solutions. And so we want to solve for H, which would be B sine of A. So that's going to be 9 sine of 25. So H is equal to 3.8. If you remember our rule where we went H is less than A, which is less than B, if that works. So H is 3.8. A, we're going to have to solve for A. And then B is 9. So let's solve for A. So we're going to do A squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12, and then the cosine of 25. So all we really need to do is put this whole thing in our calculator, and we get A equals 5.4. So when we put that in here, we can see that this applies. Therefore, we know that we have two different angles, or two different triangles. So to find the sine of B, or to find the angle of B, I'm just going to use sine because we just solved it, right? So we know A is equal to 5.4. So now we can use the sine, which is always easier. So the sine would be 5.4 all over the sine of 25 is equal to 9 over the sine of B. And then when you cross multiply, 5.4 sine b equals 9 sine 25. And let's go here. So b is equal to the sine inverse of 9 sine 25 all over 5.4. So then b is 44.8, which means c is going to be 180 minus 44.8 minus 35.2. So, I'm sorry, not 35.2. Okay, 44.8 minus 25, so it equals 110.2. And we already know what a is, so here's your first solution. All right, so let's go to our next solution. And so our next solution, that's for B1 and B2. Oops, I should have highlighted this. This is B1. So this is the complete solution. We already knew what A was. For our next one, for B2, we're going to go 180 minus 44.8, which equals 135.2. And we already know A is 25. So C is going to be 180 minus 25 minus 135.2, which makes it 19.8. That gives you your two solutions. Go ahead and pause, and let's see if you can get the checkpoint. Okay, the checkpoint was B is approximately 59.66 degrees. C is approximately 40.34 degrees. And A is 18.26. Okay, so we get to do a word problem. Yay! Okay, so anyways, with the word problem, let me get back on my blue. What we're trying to solve for is we're trying to solve for H. So really, we can just plug it in. We have an angle and two sides. So we've got H squared is equal to 43 squared plus 60 squared minus 2 times 43 times 60, and then the cosine of 45. And put the whole thing under the square root, and you come up with H is approximately 424 feet. All right, go ahead and pause, see if you can do the checkpoint, and then come back and I'll tell you what the answer is. Okay, the answer is approximately 202 feet. Yay, a bearing one. They gave us the picture, thank goodness. So all we're going to do is we're going to try to figure out what is the bearing from point B to C. So we need to find out the cosine of B. So to do the cosine of B, we're going to go ahead and go B squared, which is 139 squared, equals 80 squared plus 60 squared minus 2 times 80 times 60. The cosine of B, do all the math, and we get, let's see, 9321 is equal to negative 9600 cosine of B, which means we're going to do the cosine inverse of 9321 all over negative 9600. When it's negative like that, just means you're going to have an obtuse angle, which if you look, B is an obtuse angle. So therefore, B is approximately 166.2 degrees. Now, if we're doing the bearing, that means we want to know how much is this little angle. So what we want to do is we just want to subtract it from 180. So the bearing is 180 minus 166.2, which will give us north 13.8, west. All right, go ahead and pause and see if you could do the checkpoint. When you come back, I'll have the answer for you. So the answer is north 15.37 degrees east. Okay, here's our another one. This is how you find the area without it being a right angle. So you can use Heron's area formula, and it gives you all the information there. So we're going to go ahead and give this a go. Okay, so the first thing we have to do is we have to figure out what S is. So S is going to be A plus B plus C all over 2. So therefore S is 45 plus 53 plus 72 all over 2. So our S is equal to 84. And now we'll use the area formula. So we're going to go S times S minus A times S minus B times S minus C. So the area is going to be equal to 84 times 84 minus 43, and then 84 minus 53, I'm running out of room, 84 minus 72, all of this is under the square root. Plug it in your calculator, and the area is 1,131.9 meters squared. All right, go ahead and pause, give yourself a go on the checkpoint, and come back when you're ready, and I'll have the answer for you. Okay, the answer is approximately 19.90 meters squared. Okay, so we're done. All we have to do is our vocab. That was a short section. And so what they're saying here is, what if you had solved for b squared, because we're looking at cosine b, so that would be b squared is equal to a squared plus c squared minus 2ac cosine of b. When solving an oblique triangle given 3 sides, you use the alternate form of the law of cosines to solve for an angle, which is like this one here, but really you don't need to do that. You can just put all your stuff in and then go for it. And when solving an oblique triangle given 2 sides and their included angle, you use the standard form of the law of cosines to solve for the remaining angles. And finally, the law of cosines can be used to establish a formula for the area of a triangle called the Heron's area. Oops, area. There you go. And then here's all of your formulas. All right, we're done.